In this video, we will discuss the basics of setting up a black or silver line IO link master from Balluff within the Codesys programming environment utilizing the EtherNet IP protocol. Quick review of the black and silver line masters. These are 8-port IO link masters. They use an M12L coded power. They are multi-protocol with Ethernet IP, Profinet, EtherCAT, and Modbus TC protocols available. Again, we'll be concentrating on Ethernet IP in this video. They have built-in REST API and MQTT capabilities. Through the L-coded power, we can bring in 16 amps on the input or sensor side, as well as 16 amps on the output or actuator side. With the advanced masters, we can push up to 4 amps per output for the pin 2s on those advanced modules. In the Blackline portfolio, we have other masters not under the advanced umbrella, where they either have 2 amps of output per port per 4 amps, 2 amps per output, or half an amp per output, and these all have different pricing structures. Basics for the black line: it has a composite shell, which is weld splatter resistant and no display. The silver line has a die-cast zinc nickel-plated shell, as well as a display, and through that display I can set the IP address, subnet mask, gateway address, and protocol. The silver line carries a slightly higher cost than the black line. In this video, I will be using masters that are currently sitting at hardware 1.0.0 and firmware 1.4.0, and the Codesys environment, where I will be using a Raspberry Pi as my controller, is utilizing Codesys version 3.5 Service Pack 22. So let's get into the Codesys environment and show how this is set up. So quickly, I'm just going to connect to my Raspberry Pi, make sure that's set. And the first thing we'll do here is we'll go under Tools, we'll go to Device Repository, and this is where I have to load in the EDS files for my IO link masters. I'll click Install, and in this case, in this video, I am using the Balluff order code part number BNI00L3 IO link master, and this is the long part number for that IO link master. So I'll click on this EDS file and I'll click Open, and I get a message saying that the EDS file was installed. So I'll close that. Now to add the IO link master to my configuration, I'll go up here to Device, I'll right click and Add Device. I'll expand Ethernet adapter and choose Ethernet and Add Device. On the left side, I'll click on this newly added Ethernet, expand Ethernet IP, expand the Ethernet IP scanner, and click on that device and add it. Going back to the left side once more, I'll click on the Ethernet IP scanner, and now here's a list of the EDS files that I've previously loaded, as well as the generic Ethernet IP device option by Codesys. And I'm going to choose this BNI XG3 508 0B5 R067, and fortunately down here below it tells me that the order code is BNI00L3. So that is the module I'm going to add. So we're going to click Add Device there. We'll close out of this window, and I'm going to double click on Ethernet. I need to point to the, I'm going to point to the my Raspberry Pi, which is my Codesys controller. Get that screen out of the way, and then I will double click on the master. I will set the IP address, which currently is sitting at 192.168.11.82. On the Connections tab, If you notice here, all the pin 4s and all the pin 2s on the module are set up for standard I/O. So the first thing I want to do is decide which ports I want to put into I/O link mode, and pin 4 is that pin carrying the I/O link communication. So on the drop down for all the pin 4s, I have options to leave that pin as a standard I/O pin or to put it into I/O link mode. I'll just go ahead and put the port 1 and port 2. I'll put both of those pin 4s in I/O link mode. For the pin 2s, you'll have the option of leaving that as a standard discrete I/O or making that what we call a power pin, or put it into power mode, and that will leave that pin on in a constant state of 24 volts as long as there's actuator power present. I'll show you that here shortly and really show you what that means. So I'll leave that as just an I/O pin for now. As I scroll down, sorry, let me jump that back to I/O. As I scroll down here, you'll note that each port has more configuration options. So for each port, you can adjust the cycle time. For 99% of our customers, leave it as automatic. Under validation type, this is where you can turn on validation, or compatibility, and that means that the master port is validating or verifying that the device that you've set up is the correct device. And then you can use the compatibility mode with the parameter server as well. And if you choose to use that compatibility setting, you would then need to enter the vendor ID of that device and the device ID for that device. So if compatibility was enabled, the vendor ID and the device ID would have to match the device that's physically plugged into that port. If not, the port would be in an error state, blinking red, showing that the device that's connected is not compatible based on your options here. So, and again, you would make those choices for each of the 8 ports. So right now, the only thing we've changed is that we've put port 1 pin 4 and port 2 pin 4 into I/O link mode. Under this menu, I'm going to click on Ethernet IP I/O mapping, and this is something I always forget, so I wanted to point out to you. In this window down here on the bottom right, there's this always update variables. You need to change this to enable 1 so that your data from your I/O link master is passing back and forth between your Codesys controller. So at this point, I've done the basics of setting up this device. So I will save and we'll download to the controller. Of course, the controller will be in a stop state once we go online. So we're in a stop state. I'll put it into run. And the first thing I'm going to verify is that these icons here are green in front of the EtherNet IP scanner, and the Balluff I/O link master, meaning that I have good communication between the Balluff device and the Codesys controller. So at this point, we've done the setup. I'm connected to this master's web UI, which is showing the LED states of it. Having the US power or sensor power solid green, the UA power or output power solid green means that my power states are good, and then the mod light and the net light need to be solid green in an Ethernet IP environment for good communication. And then my Ethernet cable is only plugged into the left port. So this is my 10100 LED. So with the LED solid green, I'm running at the 100 baud rate, 100 megabyte baud rate. And then the indicator that's flashing is showing that I have Ethernet activity on that port. If I was utilizing the right port, the same two LEDs over here on the right would be representing the 10100 and active communication on the right port. If I notice here, the only thing I made changes to this device or to this master was I turned on pin 4 on both the port 1 and port 2 into IO link mode. I do have a device already connected to port 1, but this wrench is showing that I do have a problem with this module, and the module is needing pin 2 power coming from this port. So I need to have this pin 1, or this LED 1, which corresponds to pin 2 of that port. I need to have that on or energized to provide the 24 volts of output power to this device. Now, what I can do here in my Codesys environment is I can scroll down here to outputs, and I can expand outputs, and I can go here to bit 1, and I can choose to make that true. And if I come back to my module here, then the pin 2 is energized as an output and providing output power to this IO link hub. And now I've got the green check mark showing that that device does not have any warnings or errors on this. Now, if you recall, we set pin 2 as a standard IO pin. So that means in my logic somewhere, I've got to energize that pin. So let me show you a different way we can do that. So I'm going to set that bit low. We're going to write that value, verify that it's low, and again, now I've got my wrench again because this module is needing that pin 2 for output power. The other way that I can turn on pin 2 without ladder code is I'll come back up here to connections. I'm going to go offline, and I'm going to change that pin 2 into power mode. I'm going to save that, and I'm going to download it. And again, we'll be in stop mode here to start. Put it back into run. And as soon as I go into run, this pin 2 is now on. I didn't write any code, or I didn't toggle a discrete IO bit to make that happen by putting the pin 2 in the power mode. As long as I have actuator or output power coming into the module, that pin will stay in an energized state. So it's up to you to choose whether you want to put pin 2 in power mode and keep that pin 2 in a constant 24 volt state, or leave pin 2 in an IO state, and then you must write your PLC code or your controller code and turn this on through your coding. So again, I wanted to refresh on that because some people get confused of what does power mode actually mean. The last thing I want to do here is if you go to the Balluff website and you look up the Balluff IO-Link master part number, you have access to our online manual. And within the online manual, it will break down the input and output data that is in your Codesys setup. So in this case, byte 0 through 7 are your standard IO for the ports on the master. But then if I have an IO link device connected to port 0, which I'll point out that the master actually shows ports 1 through 8, so you want to offset these by 1. So port 1, if you're looking at the master, that data starts in word 8 through 55, And then below this is the breakdown of how those bytes are broken down. And then you have the output side of the master as well. I wanted to point that out because if I come back in here to Ethernet IP mapping, you've got the standard I/O, but then you've got your port 1 byte 0 through port 1 byte 31. So there's your 32 possible bytes of input. And then you have your status information and your error information and your vendor and device ID and event data. So the online manual would clarify further what do these bits in the status show. In this case, I have the pin 4 in IO link mode, which is the first bit, and the second bit is showing that there is an IO link device connected to it. If I go down to port 2 status, that was the other port that I had in IO link mode, and the pin 4 is in IO link mode, but no device is connected. And if I were to connect a device to that, which I'm doing right now, we will see that second bit come on, showing that there is an actual device connected to it. So again, that's explained in further detail in the manual. So for example, here is those two bits I was looking at, the bit 0, which is the IOL bit, so that's telling me that the port is in IO link mode, and the DC bit that there is a device connected. So again, this explains all that information. So I hope this video will help you in the future to set up a black or silver line master. And again, I'll point out there are 4 different black line masters. There are 4 different part numbers for the black line masters. There are 2 different part numbers for the silver line masters. And it doesn't matter which of those 6 IO link masters you use, the setup that I shown would be the same for each of those masters. So again, I hope that in the future this video can help you set up a Balluff Black and or Silverline IO link master within the Codesys environment using the Ethernet IP protocol. Thank you.